Okay, so for problem number 1 here from this particular homework assignment, note that with a sequence, we number the terms. So my first term is called A1, my second term is called A2, my third is called A3, etc. And the number in the subscript is often called the index of the term. So this is the index 1, right? Index 2. And what's interesting about sequences is that the value of the index, the value that tells you, is it the first term, the second term, the third term, etc., that becomes part of the formula to compute the value. Okay, so for example, they're telling me that this sequence has the formula 9n minus 3. Note that the variable within the formula is the index. Okay, so in this case, since my index in the first term is 1, we can just use 1 within the formula. So for example, this is 9 times 1 minus 3. This is the formula that gives us the value of the term. And what's interesting again is that within the formula for the value of the term, we're using the value of the index within that formula. So that takes a little bit getting used to. Okay, but once you get used to it, it's pretty easy. Okay, 9 times 1 minus 3, of course, is going to be 9 minus 3, which in this case would be 6. Okay, if they ask me about the second term, etc. Okay, so this would be 18 minus 3 would be what, 15? Right? Again, this A3 would be 9 times 3 minus 3. This would be what? 27 minus 3 is 24. This would be 9 times 4, take away 3. This is what? 36, take away 3 is 33. Now, we can go a little bit further here. If you note, look at what the spread is between the terms. If I do, how much you have to add to 6 to get to 15? Looks like you have to add 9, right? How about here? You have to add 9, right? How about here? You have to add 9. Why are we always adding 9? Because you can think of this formula for the value as kind of like a y equals mx plus b. Linear. The m would be the 9. The x, that's a 9, sorry, not an a. The x is like my n, okay? It's my variable. That's my n, okay? And then in this case, my plus b would be plus negative 3. So I can think of this as y is equal to 9 times n plus negative 3. So my y-intercept, or starting value, that's my starting value, or y-intercept, is negative 3, okay? The number multiplying your index is like the slope, m, in this case. Okay, so that's my m. Okay, and then again, the n is acting as my input, like my x. Okay, so remember, with a linear function, you do increase by the same amount all the time. As long as you're moving up by 1 unit on your inputs, your outputs will always move up by whatever the slope amount is. Okay, that slope amount. The slope tells you how much you go up by. So that's your increase in the output every time the input goes up by 1. So when the input increases by 1, that says increases, sorry. So when your input increases by 1, the slope tells you how much your output increases by. So in this case, it would be 9. Notice my input is going up by 1 here. These are my inputs. The subscripts or indexes for these terms are my inputs. My inputs are going up by 1, and consequently my outputs are going to go up by 9, because that's the slope of the line. That's the slope of the linear relationship. Okay? So we're going a little further than what the question asked. The question just wanted you to find this value, but we're just trying to understand that this particular sequence is describing a linear function or a linear relationship. Okay? You could also write it in mx plus b form if you wanted to. And there we go. Now the only difference would be with mx plus b, you could plug in an x that's like a fraction or something, an input. With the sequence version, these indexes are just always whole numbers. So the difference is, if I graph it, okay, what would the graph look like? If I graph the line, here's my x, here's my y. My y-intercept is negative 3, and my slope is 9, so it would look like this. Y equals 9x plus negative 3. Okay, what would the sequence look like if I graph it? If you graph the sequence, it's only, basically, you're just plugging in whole numbers. Okay, so here's my n instead of x. Here's my an, the output instead of y. And we can plug in 1. At 1, we're getting a value of 6. Okay, so at 1, we get a value of 6. At 2, we're going to get a value of 15. At 3, we're going to get a value of 24. Whoops, sorry about that, etc. So essentially, we're just picking up the whole number inputs that would exist within the line equation. So if I just use whole number inputs, I'm essentially, that's what the sequence is doing. It's the same relationship, but we're only using whole numbers as inputs instead of all possible x's, including the fractions. Okay, basically same pattern. All right, so we've gone a little bit further into what's happening here, but that's good because it'll also give us some practice with linear functions. All right, so let's go on to number 2. Okay, here's problem number 2. Whoops. Okay, here's problem number 2. Sorry about that. And again, similar setup. They just want us to start listing the terms. A1, A2, A3, etc., just like before. And again, remember that the value of what we call the index here, the index of the term, becomes an input into the term, into the value of the term. Okay, so they just want to know the first term. Okay, they just want to know what A1 is going to be. So it should be pretty easy based on what we did before. So I'll tell you what, I'll just do A3 for you. A3 in this case would, I'll do A4. So A4 in this case would be what? -3 times the n value of 4 plus 8, right? Which would be what? -12 plus 8. -12 plus 8 is -4 in my case. Okay, so that would be, they want to know this one. Okay, they're asking you for the first term. So based on what we just did here and what we did on problem number 1 a minute ago, you should be able to easily get this answer. Okay, all right, cool. Okay, we're on problem number 3 here. So on problem number 3, they want the 7th term of the sequence. So 7th term essentially means my index value would be 7. So I would have to just build my terms, A1, A2, ... all the way down to A7. Okay, and we could go beyond that, but they're just asking about A7. Okay, so how would I find that? Well, I'll just do one of them. I'll do the first couple with you, and you can figure out the rest. Again, the formula is pretty straightforward. The only issue here is that the input to the formula that generates the value of the term is actually the index number. The index number becomes your input. That's what's a little bit unusual about sequences. Okay, so in this case, my A1, the 1 is my input. Okay, so it's going to be 1 times my input plus 3, and my input here happens to be, let's kind of change colors just so it's clear, my input happens to be 1 because my index is 1. Okay, for my second term, the formula is 1 times the n plus 3, and in this case, my n is 2. In other words, again, the index of the term becomes your input. Okay, the index of the term becomes your input. Okay, and we can just continue that pattern. You should be able to easily figure out what your 7th term is, or whatever. It's likely it'll ask you for some, you might not be asked for the 7th term, you might be asked for something down the line, but it's easy to figure out at this point. Okay, all right, great. Let's go to the next one. Okay, so in this problem, we are in problem 4. We have a formula for the terms of our sequence, and again, remember the issue here with sequences is that the index value acts as an input into the formula. Okay, so for example, my first term, A1, would be, I would use the value 1 for the index of the term as my input. Okay, so my index is 1, so my input into my formula that determines the value of the term is going to be 1. Okay, so of course this would end up being what? Just remember order of operations. If I square the 1, I get a 1. 1 times -5 is -5. -5 plus 5 is 0, so this would be 0. Okay, I'll do one more with you. Let's go to A2. So for A2, remember the formula is the same. -5 times the input squared, but the input is actually the index of the term, and plus 5. So in this case, my index is 2, so that becomes my input. And so 2 squared is 4, order of operations, exponents come first, right? Well, actually, parentheses is first, then exponents. So 4 And then multiplication division, so 4 times negative 5 is negative 20. Negative 20 plus 5 would be negative 15, right? Okay, so they want you to go ahead and generate, in this case, the 8th term. They want you to go all the way down to A8. Now, technically, you don't need to generate all of them to get the result. Okay, you can just jump right to A8. All right, that's because this is what's called an explicit way of writing the formula for the terms of the sequence. You can just jump right to any particular term. Recursive is when you have to generate all the previous terms to get your next term. In this case, I can jump right to the 8th term. I don't need to generate all the previous ones. This is not recursive. This is explicit. You can explicitly go to the 8th term and just figure out what it is. Okay? And by the way, this is not a linear relationship if you look at it. It's got a square on the variable, a square on the varying quantity, which means it's a parabola. Okay? A quadratic relationship. If I would think of it as a function, it would be the function y equals negative 5x squared plus 5, which would be a parabola opening downwards, starting at a height of 5, like this, going down in both directions. If you remember your parabola stuff, your quadratics, okay, that would be a graph of this function. What's a graph of the sequence, the corresponding sequence look like? Similar pattern, it's just that we're plugging in only whole numbers as my inputs, no fractions in between. So it would look like this. So it's going to start at a height of, it's going to start up here. When the input's 1, we get a 0. When the input's 2, we're going to get a negative 15, etc. Okay, we're running out of space here, but the idea is it's looking like this. Okay, so it's just kind of, we're not getting the stuff in between. We're only getting the whole number inputs. Okay, so we're like getting little dots along here. A dot here, etc. Okay? The reason we're not getting this one is because we're not doing an A0. If we did an A0, then the input would be 0. And the and A0 would be 0. I mean, 5, I'm sorry. So, for example, if we, in theory, did an A0, it would be negative 5 times 0 squared plus 5, which would be 5, and that would give me this value of 5 up here. Okay? We're starting at 1. Okay? So we're considering our sequences to start with an index of 1, and so when the index is 1, when the input is 1, we're getting this value. We're getting an output of 0, a height of 0. When the input is 2, we're getting a height here of negative 5, etc. Okay? The next one will be negative 15 way down here. Okay? So we're essentially just getting these little dots. We're getting a dot here, a dot here. We're getting dots along. The function itself will allow, you can plug fractional x's in there, so I can get all the little fractions in between and figure out what the heights are. Okay? With sequences, we're just plugging in the whole number inputs. Okay? But it follows the same pattern. All right, so let's go on to number 5. Okay, so we're on problem number 5 here. And the 5th term of the sequence. So in this case, what we notice here is that there's no n in the formula. Okay, so n is my index, and if I go to plug it in, we don't know where to plug it in. There's no n in the formula for the sequence. If there's no n in the formula, that means that the value of the sequence, the value of the terms, does not depend on the index. The value in this case is just always going to be 7, no matter what the index is. Okay, so if I begin to write out my terms, the terms would look like this. A1 is 7. The 1 itself has no role to play. A2, 7. A3, 7. This is just what's called a constant sequence. Okay, so it's a really easy question. It's just a good sort of little practice just to get used to the idea of, you know, that the value of the terms typically does depend on what the n is, but not in this case because there's no n within the formula for the sequence values. Okay? All right, so let's go to the next one. Okay, so here we are on problem number 6. And in this case, they're telling me that my first term is 5, or negative 5, I'm sorry. And now they're telling me here that each term, which we can call an, equals the term before it is going to be called a subscript n minus 1, because remember the index, if you drop the index by 1, which we're doing in this case, that means you're backing up one term. Because we're subtracting 1 from the index, That means we go back one term. So this is the term before the current term. And plus, we're also doing minus 7. So each term an is equal to the term before it, which is called an minus 1, minus the quantity 7. So we subtract 7 off of that value. Okay? So now this is, what's interesting here is that I can't just jump to, let's say they want the 7th term here. Can I just compute the 7th term right off the bat? Can I just jump to the 7th term and get a value for it like I could in the previous problems? And the answer is no, not in this case, because the 7th term is going to depend on the 6th term. Because the value of the 7th term would be the value of the 6th term minus the number 7. So how would I compute the value of the 6th term? Well, that's going to be the value of the 5th term minus the number 7, etc. So each term depends on the one before it. That's called a recursive sequence. Everything depends on what came before it. So this is not explicit. This is recursive. Recursive is the opposite of explicit with sequences. Explicit means you have a formula to generate any term you want and you don't need the ones before it. Recursive means you have to have the previous terms to get the current term. Okay? So with recursive, you have no choice. You got to just start at the beginning and build up. So in this case, my A1 is easy. They gave it to me. Now my A2 is going to be the one before it. What's the term before A2? Right now, my n is 2. Right here, my n is 1. So for n equals 2, if n equals 2, then what's n minus 1? If n equals 2, then we can just think, okay, well, n minus 1 is going to be 1. Okay? N minus 1 is 1. In other words, A2 is really A2 minus 1. 2 minus 1 is 1. In other words, term A1, the term right before it, that's my n minus first term. If 2 is my n, then my n minus 1 is going to be term 1, and then minus the number 7. So it's the term before it minus 7. Okay, and the term before it happened to be negative 5. So negative 5 minus 7 is negative 12. Notice I needed the term before my current term in order to get the value of the current term. Okay, now how would I do n equals 3? Let's maybe change colors here a little bit. For n equals 3, that means my third term is going to be what? The term right before the third term. What's the term right before the third term? The second term. What is the value of the second term? Negative 12, okay? Minus the number 7. Why am I minusing the number 7? Because they're telling me to right here, okay? And what do I get? What's the term right before the current term? What's my A2 value? Negative 12. And then I'm going to minus the number 7. Negative 12 minus 7 is negative 19. Okay, let's do A4. Okay, so when n is 4, my fourth term is going to equal the term right before it. What's the term right before the fourth term? If my n is 4, for example, then my n minus 1 would be 3. Okay, so this would be A3, and then take away the number 7. Now what is A3? A3 is the value of the term that came right before the A4th term, the A4. Okay, so A3 came right before it, and that value was negative 19. So I'm going to have negative 19 minus 7, which is negative 26, right? Okay, and they want me to keep going. I'll do one more with you, and I'll leave the rest to you guys, okay? So let's do, let's see, that's a good color. I guess we'll go purple. We'll go light blue. Okay, let's do n equals 5. So my fifth term is going to equal what? The term right before it. What's right before the fifth term? The fourth term, and then take away the number 7. What's the value of the fourth term? Negative 26. Minus the number 7, which is what? Negative 33, right? Okay, and we could keep going. And that's it. Fun, 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 right? Okay. So in my case, you should get, for the version I got of this problem, your final answer for the 7th term should be, if you follow my numbers, you would get negative 47. Yours is probably going to be different because these are randomized. You'll have a slightly different version of this, okay? But my answer should be negative 47. Yours might be a little different. So go ahead and continue mine to see if you get the negative 47, and then once you master that, then go ahead and try your version, okay? All right, cool. So let's go on to the next one. Okay, here we are on problem number 7. Now, in this case, this is recursive. Recursive means that I need to know the values of the term or terms before my current term in order to get the value of the current term. So in this case, what's interesting is we have a two-step or two time period recursive relationship, because we have to go 1 unit back and then a second unit back. So this is 1 unit back, or 1 index back. I'll just call it 1 unit back, or 1 term back. This is 2 units back of the current term. So you have to know the previous 2 terms to get the current term. So to get the current guy, AN, I need to know the guy before it and the guy before that. All right, which means that I won't be able to compute anything new really until the 3rd term, because the 3rd term will depend on the 1st and 2nd. So they have to give you the 1st and 2nd. If they want you to go 2 units back, they have to give you the first 2 values, which they are in this case. Okay, so we can begin. So my first 2 terms are easy, that they gave them to us. Okay, the 3rd term is where we begin to compute. So the 3rd term is equal to simply the term before it plus the term before that. Okay, so this is going to be the n minus 1. This would be, so if n is 3, then n minus 1 would be 2. So this is my a2. And then n minus 2 would be what? 3 minus 2 is 1. So this would be my a1. Okay, this is 1 unit back from the current. This is 2 units back from the current. Current is A3, so if I go 2 back, I get to A1. 1 back gives me to A2. Now, do I know the value of A2? They gave it to me, right? So I know it. It's going to be, there it is, it's a 1. Okay. Do I know the value of A1? Well, yes, I do, right? They gave it to me right there. Okay. And can I add those up? That's easy peasy, right? 1 plus 1, I'm getting a 2. All right, let's go to A4. A4 is going to be the sum of 2 terms, because I see right here it's 2 terms being added. And what are those 2 terms? I have to go 1 back and 2 back. Okay, so in this case, I'm going to go, in this case, my n is 4. So if I go 1 back, that's going to be A3. Right, that's 1 unit back from 4. Right, because 4 minus 1 is 3. So the next 1 back would be term 3. 2 back, going 2 units back would be term 2. So I'd go back to A2. Right, that's 2 units back from where I am currently. So let's get those numbers. Okay, so 1 unit, excuse me, let me do a different color, I guess, here, one we haven't seen. Well, I'm running out of colors here. I guess I'll go with the yellow. All right, what's 1 unit back? 1 unit back is the A3. The A3 has the value of 2. Okay, plus 2 units back. 2 units back is A2. What's the value of A2? The value of A2 is 1. Okay, and so 2 plus 1 is, don't even need a calculator for that one, 3. Okay, let's do one more, just because we're having so much fun, right? Aren't we having fun? I think we are, right? Let's go to A5. So A5 is going to be 1 guy back plus 2 guys back. 1 guy back is going to be what? 1 guy back is going to be A4. If I go 2 back, it's going to be A3. So what is the value of A4? Well, we just figured out A4, right? The value of A4 was 3. What's the value of A3? The value of A3, right here, was 2. So 3 plus 2 is, I'm thinking 5. You guys thinking 5? I'm thinking 5. Okay, let's try one more. A6. A6 is going to be, whoops, we're running out of a little room here. A6 is going to be 1 back plus a second back, 2 back. Okay, so I have to go 1 back and then another guy back. So I'm going to go 1 back would be A5. Whoops, I'm running out of a room here. It doesn't let me write at the bottom of the screen. A5 and A4. Okay, so what's the value of A5? The value of A5 is 5 in this case. And then if I go back to A4, the value of A4 was 3. And 5 plus 3 is kind of like 8, right? etc. Okay, and we would just keep going until I get to the 9th term. Now, can I skip ahead and just jump right to the 9th term? No, because the 9th is going to depend on the 8th and the 7th. Right? And the 8th will depend on the 7th and the 6th, etc. So you have to generate them all to get to the end. Okay? So in my case, I should be, for the 9th term, the answer you should get for mine with the numbers I have here should be 34. So if you continue this process, you should get to 34 to get when you get to A9. Your A9 in my case with these numbers is 34. Okay? But you'll have different numbers in yours. Okay? All right. So let's go on.